All right, we got us a same kind of unit. They're pretty much all the same around here. This one is not working. Compressor's not running. Equalize pressures, but no compressor. It should be running right now. It looks like it's on. So we'll see what we can find out while we got no power. Get into the or power now. Oh, look at that. Oh, that must have been previous. No, looks intact. I do believe, yeah, top two lights. Well, not the very top one. That's power light. These two are together. Top one is the drive, the gear motor, and the other one is the compressor, which should be running. But we got nothing. We got no compressor, and I am going to assume it's the relay on here. That relay, but I'm gonna go ahead and try to test it out. I know as soon as I touch it, it's going to energize. We'll put a meter here, check amp draw, and voltage. We got nothing. This should be my comment to my compressor. This should be our one. There we got 119 volts. We should be running because we got power to our compressor wire. Yep, that's compressor wire. That's fan wire. We got nothing here. Well, so it's not going to be the relay. Well, compressor relay. I haven't seen it pull any amperage, so I'm wondering if we have a bad overload over at the compressor. I do believe this is my overload right here, or it goes to my overload down there. Right there. This has got to be my compressor. This is this compressor. This is compressor, and this is compressor. Red, black, and orange. Red, compressor. Oh, well, look at that. Maybe we gotta check our high pressure switch. Right there. High pressure switch. So we got power here. We gotta check the high pressure switch, and then we can go to overload. So let me check that. All right. I don't think it's open. Since we're doing on rating on this, 0.2, I don't think that's open. So next step would be the overload, which I guess let me unplug and pull this unit out. I gotta take these screws off, pull this unit out so I can get to overload, which is right over there. All right, we got it now. Just need to get it forward enough to be able to pull the compressor cover off. Ah, we can get there. Double check, it is unplugged. I'll test it right there. There we go. You got open overload. That's why we got no compression. All right. Oh shit! I thought I had to take this plastic thing off. No. Oh, look at that. That ain't bad. All right. Maybe we'll get another overload. We should have some in the shop. And I'm gonna go get my measure and check. Let's check the ohm reading here. 4. Let's say 4.6, 0.8. That would be 5.6. No, 5.4. 5.4. It was 5.4. 5.2. 0.2 off. That shouldn't be too bad. Let me get my measure and meg it, and we'll replace the overload, check the relay, and start the capacitor, check the amperage. So I'll be right back. All good. That one's good. That was good. And if it didn't have a connection, it'd be right there. And if it had a connection, then that works. But we got a good connection there. That's what I was kind of worried about. But read's good. The insulation's good anyway. It ohms out good. So let's drop in an overload and let's start it up. See if it'll run. All right. Black goes at the bottom. Orange goes here. And red goes up here. That's that. All right. All right. That's off. So let's plug it in. We ain't got no water hooked up to it, but it's got a little bit in it. Hopefully it can make it run long enough to check amperages. Oh, I need tie wraps. $14 amps. We're allowed 14 amps. Total, I would imagine. I wonder if the compressor says anything. It doesn't say anything, but I'm sure we can look that up. All right. So this will be my total amps, I believe. Right here. 1.9. So that's just my gear motor running at this moment. So let's see what we got. Oh, I didn't like it. That's 40 amps. I did not like it. All right. Let's see if we can get any amperage through the start capacitor. 0.6. Why am I getting a reading there? 0.2. There. Reading something else or something. Maybe it wasn't closed right. 0.6. $37. Alright, so we're overamping, which is probably what caused the overload to go out. Constantly trying to open and close. So let's check the start capacitor. Remember, always discharge your start capacitor. That one didn't have anything on it, but you never know. I did unplug the machine. $378, $440. Wait a minute. Home. Continuity. Oh, what am I doing? Hitting the wrong damn button. No wonder. There. It's a new meter, and I'm used to the select button being right there where the wireless one is. Anyway. Uh-huh. Let me get my alligator clips, but I think we got a bad capacitor. Sure got on the right setting. UF, right there. All right. The add start capacitor. Let me go find one. All right, I found a capacitor, but its size is different, so I don't know. It's not going to fit in the bracket that's in there. But I do want to test it out. There we go. 393, 378 to 440. That one's not reading nothing. So what I'm gonna do is I'm going to put this on and test run it. See if it'll come on. And hopefully it's not the see how the capacitor is bigger than the bracket, so Well, this is the same thing. We'll do that. Whoa, don't move. Now we'll get a reading through the start. Let's see if that gives us a reading. And our common, if that gives us a reading for amp draw. And if it works, I'll pick up new start components tomorrow. So which would be put it here. All right, I know it's upside down, but bear with me. Oh, there we go. 7 amps, 7.5 amps. 7.2 amps. You got water in there. You see if that will see if that comes up. It needs to be somewhere around 30, 28. It seems to be that pressure seems to be going up. That seems to be climbing. Saturation temperature seems to be climbing. I'd like to see that about 28 psi. You're not far. There's water in here. This should still make ice because there's water in the evaporator, water in here. It'll make ice with whatever water it has, and then it'll shut off on low water. But you can see it. I can see the water level coming down gradually, so it's making ice. We might be okay. I'll get a start component kit and bring that tomorrow maybe and fix that up. I'll put this together just so it doesn't get lost. We'll get it fixed up tomorrow. Perfect. Now, we'll change this relay. What did I do with the other one? Oh, it's right here. When the stock capacitors go out, I like to change the relay and capacitor because you never know what took it out. Could have been a relay sticking all of a sudden. All right, it's on. Let's get an amp rating, turn it on, see what it's gonna do. Came right on. 8 amps. 8. No, 7.4. 7.1. I think that's gonna do it. So was not running. Troubleshot it to the overload on the compressor. That was bad. And that was bad because it kept trying to come on and off, or it kept over amping going off on overload because the start capacitor was bad. You got a bad start capacitor, you change your relay. Change them both. Same time. Because that could have just gotten stuck at one point and took out that capacitor. So you want to change them both at once. Just to eliminate issues. I mean, it could be good, but it's cheap enough to just replace it. Might as well. So brand new relay, brand new capacitor, and brand new overload. And I think that's going to do it. Oh yeah. You can see the, well, I don't know if you can see it, but I can see the water level right there. It's going down, which means we're making ice. And it's going to shut off on low water. Just because I don't have it hooked up to water, I just got it hooked up to power. But I know it's going to make ice. You can see it right there. You can see the ice moving in there. That sucks. All right. Well, that's fixed.